So that would be whatever the
All right, guys, so you missed yesterday. Several of you came up and got this. This is the one from yesterday. I have an improved version of the back I'll give you today, along with some other new stuff. We did the cube root yesterday, but just to kind of go back and review, what's the square root of 144?
12.
Why exactly?
Because 12 times 12 is 100.
I like it. It's the square root, so it's asking you, what does it take 2 of to multiply by the inside? That's the question. Now, let me say this. How many of you guys are going to go on to, like, pre-calculus? Anybody? All right. And a few of you are like, I don't want to think about that, right? As you go further in mathematics, you're going to learn more and more symbols. There's one called logarithm we're going to talk about later this semester. There's trigonometric stuff, sine, cosine. So the big thing with those, every symbol you got to internalize what the question is that it's asking. It's in a different language. It's in Mathish. And you got to internalize how that translates into English. And the square root symbol is one you've already done. You've internalized the meaning to a point, but if you really analyze it, it helps you do higher level roots. So, for example, so if I can write down here, because 12 times 12 is 144. Yay! It takes 2 12s. So what's the, let's see, what is the cube root of 125? Yeah, that one you should remember from the cubes. We did 125 a couple times at least. Why is it 5? Because 5 times 5 times 5 is 125. So do you see how it does the opposite of a cube? A cube would say, so if I did 5, I have 1 5 there, don't I? One little 5. And if I put a cube next to it, it makes it 3 5s all of a sudden. It takes that 1 5 and makes it 3. So what a cube root does is it makes these 3 5s become 1. It does the opposite. Cuts it in thirds. I like it. All right, so then how would I do this here? What you got, Jeff? Let's do the 5th root of, let's see, negative 243. Don't say it. You know it. All right, first off, can I do it, period? Can I do that one at all? Yes, I can. Good. If that would have been a what kind of root? I wouldn't be able to do it.
Even root.
Even root. I like it. So if I gave you a problem like 6th root of negative 1 million, whatever the shit, before you start breaking that thing down, just go, oh, it's not real. I'm not going to do anything. Just put not real, move on. So that's a good thing to look for first. It's an odd root. I can do positive, negative, it doesn't matter. Now how do I start to attack this then? What's that symbol here mean? Yes.
Would it be 3 minus 3?
So it might be 3, but that means that there would be 5 3s that make 243. And does 3 go into 243? Don't tell me yes because your calculator said so. How can you tell me just looking at it that 3 goes in? Not because there's a 3 there. That's not good enough. Yeah, 2 plus 4 plus 3 is a multiple of 3, so 3 must go in. So this will be 3 times 81. And 81, you guys remember 81? How many 3s is 81 made of? 2 9s, so 4 3s. Bam! So therefore, the 5th root of negative 243 is? No?
Negative 3, sorry.
Negative 3. I like it. Wow, Jeff. See, what I always do is I make sure I can do it. If it's negative inside of an odd root, I don't care about the sign. I'm going to just put the sign on at the end. I just care about the number at first. I'm going to try to carry the negatives through the thing. All right. How's that so far? Is that decent? Yes?
So, if it was like an even number, how would that work?
If it was an even root of a negative, it would not real.
Oh, okay.
I'm pretty soon, by the end of this chapter, that's not going to be good enough of an answer. There'll be something you can do with that one. Oh, we'll learn what the square root of negative numbers are. They don't not exist, right? I love double negatives. They don't not exist. They exist. They mean something. They have physical meaning. Imaginary is a stupid word for poor little dudes. Dudettes, I don't know how to tell the difference. The biology of these things. All right. How are we doing? Yes, good. All right. We did this stuff last time. It's really just plugging in and then evaluating the root you end up with. It's just reminding you about functional notation. I like it. Now this one, I didn't put this on the new improved sheet, so let's do this here. Some of you guys have gotten a little bit ahead in chapter 10 homework, which kicks ass. So tell me this. Sean, are you good? What is the idea with the square root? What am I not allowed to put in?
Can't get it.
What you need?
The 10-2.
Oh. No, I'm not ready for that yet. Here, get out. What did I just say? Old man Jeff. Oh, wait. So what is it I'm not allowed to put into a square root? Negative. So what must the inside of a square root be? What kind of number? Don't say positive. Oh. Must be at least 0. Because where did negative start? Right below 0. So if it can't be negative, it has to be at least 0. What the hell does at least 0 mean in Mathish? How do I write at least 0? Inside has to be at least 0. So here it is in English. Now which kind of roots does this work for, by the way? These are all the same root. They're all square roots. So this idea works for what kind of roots? We just said this earlier. What kind of roots are uptight? More than just square roots. Even roots. We said this earlier, remember? Even roots cannot handle negatives on the inside. Odd roots can. Odd roots very laid back. Even roots very uptight. Right? So for this first problem, this is awesome. You've got to understand this. Every time you have a domain question, say in English what has to happen, and then translate that into math, solve it, you're done. Every freaking domain problem. And you're going to have a ton of them if you get into pre-calc, for example. And you're going to have a few in here too, so don't get too excited about not going to pre-calc. So what is the inside? Awesome. So 3x minus 1 is the number that's inside. And it's got to be at least 0. How do I write that? What?
3x equals 1.
No. It's got to be at least 0. Greater than or equal to 0. I like it. That implies an inequality. At least 0 means that entire side of 0, including 0. Do you guys see? I said in English what has to happen. And you guys all are cool with it. Of course you are. The inside's got to be at least 0, Jeff. Holy shit. That's what we know about even roots. And then I translate that into Mathish. Now, can I solve this? Yes, of course. It's Mathish now. I can solve this. Add 1 divided by 3. I get x has to be at least 1/3. Give me something that's less than 1/3.
1/6.
Thank you so much. So if you put a 1/6 in there, 3 times 1/6 is 1/2. 1/2 minus 1 is negative 1/2. Can I do the square root of negative 1/2? No, not because it's 1/2, because it's negative. I like it. So you can kind of check your answer a little bit. Just take a number that doesn't do this and see if it freaks out. You guys do the next two. Again, don't be freaked out by this. What's the first word in the thing that we said in English? Inside. The inside has to be at least 0. Caesar, oh my gosh. Say? Okay. Jonte. Eduardo. Eduardo. Bocan. Bocan. Ernesto. Ernesto. Belinda. Belinda. Asia. Asia. Alejandro Farson. Carmen. Renee. All right, you guys done yet? How do I set up number 2? Yeah, the inside, so who gives a shit about this guy? The inside, 4 minus x, has to be at least 0. And then how do I solve that? Yeah, you could, and then divide by who? Negative 1. So you get x, and you can make that interval notation, you can graph it, right? If I ask you to, yes?
Is that always going to be at least 0?
Yeah. Think about what's the fundamental idea behind keeping the answer to a square root real. It doesn't change. The inside has to be at least 0. Yeah.
But that's only for even.
Beautiful. Even roots. So we'll do an odd root example in a minute. Now what about, anybody get the idea? Anybody get the idea of this one? We've seen something like that before. Yeah, why? Because x squared, what's the smallest x squared could be for a real number? No negative. When you square a real number, you get... Okay, all right. When you square a real number, you get a what kind of number? Always. Oh, okay. What is negative 7 squared? Positive 49. No, you're overthinking it. Not square root of something, not the square roots of something, squaring something. Right? Squaring something means multiplying by itself. So they're either both positive, which becomes positive, or they're both negative, which becomes positive. Oh, shit. So it's always positive, or at least 0. So if the smallest x squared can be a 0, and I'm adding 4 to it, can the inside ever be anything other than at least 0? The inside is always at least 4. Do you guys see that? Can I make x squared plus 4 become 0? No, because x squared can't be negative 4. I can't even make it equal 0. The inside is always positive. I need you to be able to see that. X squared is always positive or 0. And then when I add 4, shit, it's always at least 4. So can the inside ever become something that would freak this out? No. We saw this before. We saw this when we did this. Can the bottom ever be 0? No. We saw this when we did these. What x's do I have to exclude here? None. I can use any x I want to because I cannot make the bottom 0. Use any real number I want to. Here, same thing. All reals, negative infinity to infinity, however you like to do it. Okay, so let's do like a cube root of 2 minus 7x. So what is it about cube roots? What can they not handle? What has to be true? Is there anything they can't handle? Can I put a positive number inside of a cube root? Yes, we've done it. Can I put a negative number inside a cube root and get an answer? No idea what word I just said, I'm sorry. Right? I could do both. And can I do the cube root of 0? Yes, it's what? 0. So does the cube root have any issues anywhere? No. So in English I would say The inside can be anything except undefined. That would be really evil. So what's the answer for almost any odd root domain question? All real frickin' numbers. Right? Odd roots laid back. They can handle negatives, they can handle positives, they can handle zero, they can handle all this stuff. It's the even roots that are uptight. It's the even roots that have to exclude entire sections of numbers. It can't handle anything that makes the inside negative. So this would almost always be, you could do it, Jeff, negative infinity to infinity. I don't know, guys, your infinity sometimes just an 8 that kind of fell over a little bit. Oh. Now here's a really evil question that I would probably not give you unless it was in a bonus. Can you guys see? It's a fifth root, so far it looks beautiful. So the root has no issues, but the inside function has an issue at what can I not put in? Don't go there, Jeff. Hey, look, there's a hole. What can I not put here? 2. Why? Because then it would have a 0 on the bottom. So the root doesn't make the domain freaky. This stupid thing makes the domain freaky, right? Even roots have problems. Odd roots don't. But you got to be careful. If they are evil and they put something, a problem on the inside, you got to be careful of that. So here, what's the domain? X cannot be 2. Or negative infinity to 2 to infinity. I like it. Just want to show an example of where an odd root might have a problem. It's not the root's problem, it's the function on the inside's problem. Okay. Right, so some of you guys have done those homework problems already, which is awesome. Okay. So let me give you this so we can keep going here. Oh, yeah. All right. This is the formal kind of definition. This is a little less formal. Where are roots on most plants? on the bottom. Okay, I like it. So my future botanists out there, don't give me that shit about, well, tubers are good in this and either. No. Most plants have roots on the bottom. I already kind of laid the groundwork for this with you guys a little bit. A square root of something, what does it do to it? If I put a 9 in there, the square root of 9 is 3. It cuts it in half, just like difference of squares. Kind of does, right? Guys. And when we say half, we don't mean like cut 9 in half and you get 4.5. That would be additively cutting in half. When we say cut it in half for roots, we mean what operation? Multiplicatively cutting in half. All right. Is everybody with me so far? What spot do I put a number that indicates that you multiply that base so many times? I kind of gave it away there. What's based on multiplication? Exponents. So if I wanted to double something multiplicatively, that means I want to square it. I wouldn't use the word double normally, but you see I'm trying to kind of connect it here. So if I want to cut it in half multiplicatively, that's still an exponent. I'm still controlling it multiplicatively, and that means exponents. So another way to write the square root of x is x to the 1/2. And I'm going to say something that sounds really weird to you. I wish we had never invented root notation. There's no need, right? What do you think a cube root would be as a power? X to the 1/3, right? So if I had cube root of x, that's x to the 1/3. You can become a 3. Can you become a 3? Yes. Let's make you a big old 1. Okay. Now, if there's a power in the problem, powers are up top. Power up top, root on the bottom. So for example, if I had the 4th root of y to the 3rd power, let's do this one step at a time, watch. So if it's the 4th root of something, it's that thing to the what power? How do you rewrite a 4th root? A 1/4 power. Is that, everybody cool with that? Because what's a 4th root do to something cuts it in fourths. So a 1/4 power makes a stupid amount of sense. I love the word stupid as an answer. So then, what do I do with those? Oh shit. Multiply. So this is y to the 3/4. Man, that's really bright. Not really, but oh my gosh. Me and 3s today are really... There we go. So I don't need this middle step, really. What's the root? 4. Roots are on the bottom. What's the power? 3. 3s are on the powers on the top. I like it. So let me skip down to here. Can you take a minute and rewrite that with a fractional power? Don't say anything out loud. This one here. All right, what you get? Why is it 7 over 3? Because roots go on the bottom. I love it. You gotta love that shit. Yes. What's up? What happened? Oh. I have people motioning me. Am I supposed to steal seconds? I don't know what that means. Suck at baseball. Everybody okay? Okay. Now let's go back up here for a second. This is going the other way. What's the root on this? 4. So I know it's the 4th root. And of what goes inside? 16. 4 through 16. And what's the power? 3. Now that sucks. If I wanted to solve this, what would I have to do first? 16 cubed. Do I want to do that? No. Stay with me now. This kicks ass. I could put the power on the inside or the outside. It don't matter. Real quick. This is why. How do I rewrite this? Now this is a little weird. You never have to do this. I'm just explaining why the power can go on the inside or the outside. This would be 16 to the 3rd to the 1/4, right? That's the 4th root of 16 cubed. But can't I put these in the other direction? Can't I say this is 16 to the 1/4 cubed? Doesn't that still become 3/4? So I can, instead of this stupid way to write it, I'm going to write 4 3 to 16 with the 3 on the outside. What is the 4 3 to 16? 2. And what's 2 cubed? 8. Bam! Now let me show you something that will blow some of your minds a little bit. I love this way of looking at this. So does it make sense that 16 to the 3/4 became a smaller number? Yes, because what's 16 to the first power? What's 16 to the first power? 16. What's 16 squared? Big number. So what's 16 to the 3/4 should be a little smaller than 16. That makes sense. It's like 3/4 of 16 in some way. And let me show you exactly how it's 3/4 of 16. This kicks ass. You do not have to do it this way unless you really like it, but this way doesn't work really well when the stuff gets big and gross. But I just want to show you this once. Break 16 up into 4 parts. Yeah, 2 times 2 times 2 times 2. This says to take how many out of those 4 parts? Take 3 out of the 4 parts. And what's 2 times 2 times 2? Frickin' 8. Same shit we just got, right? That's how it's 3/4 of 16. It's 3/4 of 16 multiplicatively. It kicks so much ass. You let it. You don't have to do it this way, but it's really kind of a cool way to remember that's really what's going on. All right, try to do number 2. Bless you. All right. Kind of understand what's going on. It shouldn't take very long. What's the root? Cube root of -8, and the power is 2. I like it. Bottom is a root, top is a power. That's too good to believe. Powers are powerful. They go on top. Roots are on the bottom of most plants. Holy shit. What is a cube root of -8?
64.
Cube root of -8 is -2. Now you could square -8 and do the cube root totally, but in general this is kind of a better way to go. So what's -2 squared? 4. Wow. Okay. What about number 3? That would be the... Number 3 would be the what root? Square root of x. And when I can't do anything to it, I just put the power on the inside. Can I do square root of x? No, just put the 5th power on the inside. Make it nice and compact. Are you good? What happened? Did you get the same answer?
Yeah.
Watch, if you square -8, what do you get?
Just have to pull it inside.
If you square -8, you get 64.
Yeah.
And what's the cube root of 64?
It's 4.
4.
4.
In general, I don't want to do that because here I do not want to cube 16 and then try to take the 4th root of that ugly number, right? Poor little number. That big number. I'd rather do the power on the outside so I don't let it get big. This one was nice. It didn't get too big. You can do it either way. Is that cool, everybody? With me a little bit? You guys doing all right? Yes?
For number 3, why don't you put the 2 on the outside?
What's understood to be there? How do we say it?
A 2.
How do you say this symbol?
Oh.
Square root. There's an understood 2 there.
Okay.
Just like there's an understood 1 here, there's an understood 2 there. But doesn't that look weird? Please tell me that looks a little weird. We don't put the 2 because we don't got 2, because we know it's a 2. Yes?
So that's the simplified version of that?
You wouldn't?
Not yet. We haven't gotten far enough to do what you might be thinking about.
Okay.
This is just purely, look, using radical notation. Simplify, we haven't learned how to do that yet. We're about to. So some of you guys might be wondering, there are a few more things you could do, but not you can't do it yet. Okay. Some of us are sleeping, but I want to, that's really needed. Oh, maybe not. Hey. All right. Look at number 2. Who's got an idea about, I mean, if it was just that, how would I do that? Rewrite that with fractional power. Yeah, it'd be x to the 2/4. All right, let me write that. So that's x to the 2/4, which I can reduce. And then y would be to the 3/4. And then z would be to the 4/4. Holy shit. And then you can just simplify what you can. So this is x to the 1/2. Y to the 3/4, z to the 1. I'm going to have to write that. It's awesome. I really have to calm this shit down. All right, poor little number 3. Now real quick, just to show you, yes? Yeah, what you do is, yeah, you could do this. You do this and then distribute. I'm going to build up to the shortcut. But I want to build it on fractions first so the shortcut makes more sense. So you're thinking about the shortcut. I love some of you guys are like, what are you doing all this shit? Because I'm trying to make the shortcut that I'm going to talk about later make sense. Wouldn't that be nice for once? Now how do I do this guy? Yeah, can't I rewrite the inside? What's the inside become as a fractional power? 3x to the
1 over 2.
All right, is everybody cool with that? Square root is a 1/2 power. So the square root of 3x is also known as 3x to the 1/2 power. And what can I do with these? I like it. Now, I mean, from here you could argue, you could do some stuff with the 3, but not really. There's no need for that. This is rewritten using exponential notation. You're done. So instead of 3x having radical stuff happening to it, 3x now has fractional exponent stuff happening to it. That's beautiful. Okay, I like it. Okay, that's not that bad. Laws of exponents. Very quickly, what do I do here? X to the 9th. Why not 14? Because, I think I've said this thing before, there is no 2 anywhere in this. There's no 2 in this anywhere. There's no 7 anywhere in here. There's no 9 anywhere in here. There isn't. What's that then? That's the number of x's. And what's that? The number of x's. So of course I got 9 x's at the end. I got 2 in a row, and then I got 7 in a row. So of course I got 9 freaking in a row at the end. Right? I'll just memorize them and see why they make sense. And then you got less shit to memorize. It just makes sense. What do I do here? Yeah, you just do the opposite. If you multiply, add, divide, just subtract. It's beautiful. Yeah, well, you're good. You just stretch. Let's see, I don't know. What's this mean? It's a 4-letter word you can say in this company. No, careful. The 3 is not being raised to a negative power. The 3 is just negative. Negative power means flip what it's acting on. So it'll be 1 over x. Yeah, I see. All right. Sorry. Started saying something, but I went along with you to a point. And what about this real quick? Yes, dear God. Never say 0. A little tear comes out for every math teacher. We don't even know why. Just a tear comes out. Oh, somebody must have said 0. Okay. So look at these. Look at these. What would I do first on this one? What kind of power is that? besides a fraction is a negative power. And what's a negative power do to anything? Flips it. So it'll be 1 over 16 to the 1/4. And what's 16 to the 1/4? How do I rewrite that? What kind of root? Fourth root of 16. And what's the fourth root of 16? Because it takes 4 2's to multiply to be 16. I like it. Try to do number 2. Please don't worry about the line. It's given to you at no extra charge.
You killed that bird again? Or that printer again, let me guess.
No, that
Kill that
printer
printer
is like a zombie printer right now. So I'm waiting for the new one that was supposed to be here a month ago.
Did it bleed?
Yay! Yay, education. Huh?
You made it bleed.
Oh, yeah, totally. I made it bleed, it made me cry. It's a nice symbiotic relationship. Now, some of you guys do some really weird shit here. You do like 1 over 1 over 20. Don't do that to yourself. Negative power means flip. So if you flip this, you get 27, and it's still being raised to the... Why is it not negative anymore? Because I did what the negative wanted me to. Of course it's not negative anymore. Otherwise it would just never stop flipping. Like, holy shit. And then what's this? How do I rewrite this? Cube root of 27. Cube root 27 is 3. 3 squared is 9. Okay. Ooh, I like number 3. You would, Jeff. You can do this. What's 8 divided by 2? 8 divided by 2. What do I do with this? Yeah, anything with a negative power goes to the other side. Reach on the flip side. So this 1a comes up. How many a's are up there already? 1. So now I end up with 2. And what's the power on that b that's up top right now? What do I do with powers when I'm dividing like bases? And what's 1 minus a half? A half. Bam. Not a hard problem. Just because there's fractions in there doesn't mean the basic process has changed. They don't give a shit. The process doesn't care what's in there. We do, because that means I got to worry about like denominators maybe. Ooh, that's in your future. And your past. Like number 4. Do number 4 real quick. If you haven't already. If any of you say x to the 3/7, you got to purge that shit. Purge it. Get it out of your system. Stop it. Right? What do I do with those powers? I add them. What's the only way I can add them is if they have line. So what is the LCD going to be? 12. So this becomes 8 over 12 plus 3 over 12 is 11 over 12. You add the powers, they're fractions, so we go, oh, I need like denominators. It's not the process just says add them. And we go, oh, the only way I can add them is if they have an LCD. Alright, let me see. These are all boring. Yes, ma'am.
For number 3, like, will be,
Why did you put it on the top and keep it 1/2? Exponent.
It's not any of what you just said. It's if I had x to the 7th over x to the 5th, what is that?
What's this?
Yeah, why'd you put 2 x's up top? What happened? No. It's just 7 minus 5 is 2. Right? 7 minus 5 is 2. Okay, I like it. Why is it not on the bottom? Well, because it wasn't negative.
Oh.
1 minus a half is a half. Why is it not on the bottom? It wasn't negative. I like it. These are boring. I'm not going to do this one because I have a bonus one coming up. All right. Before I go to the back, any questions on what we just did? I mean, the basic idea is that fractional exponents relate to roots. And then all the old properties of exponents, why in the hell would they change? Mathematics, we have a process, it doesn't change. We go, oh, there's fractions here, or there's negatives, or there's whatever, and we go, we got to handle that. But the process says, add these powers, or divide, or subtract the power, whatever. Just because I throw fractions in doesn't change everything. Real quick little look ahead to the back here. Push into chapter 10 here. I give you examples of 2 kind of ways to do this. This, to me, feels like reducing a fraction in a way. So, for example, if I have the square root of 28, what is the square root of 28? I don't know. Can somebody give me a decent estimate? What's 28 just barely above that I could do the square root of? 25. What's the square root of 25? 5. So the square root of 28 is going to be a little more than 5. So if you had to give me a number, you go maybe 5.1 or 5.2, yeah, right? Do you guys understand that? And I know you can plug in the calculator to get the exact answer, but that means you didn't do shit except this. So I'd rather do something in your head. The square root of 28, though, does have a part that I can do something with. So to be honest, this is a lot like making mixed numbers. Let me show you something really kind of cool that you might have never seen before. If I had 28 over 9, could I make that into a mixed number? And you guys have a way to do that, right? How do you make that into a mixed number? How do you make that into a mixed number? You divide, and then see the remainder, right? Now let me give you a better way to do it. Why does 28 suck? What's a number below 28 that I would have rather had up there? 27. Go with me, guys. I don't know if you guys have ever seen this before. 28 is 27 plus 1. See how there's an extra frickin' 1 on the top, right? Only that one there, but oh well, too bad for me. I'm a mixed number, look at me. So now I can do this. 27 over 9, which I can do, plus 1 over 9, which I cannot do. So then I do the part I can. What is 27 divided by 9? 3. And I don't do the part I can't do. Bam! We call it mixed because it's a whole number and a fraction. I like it. Now watch this. Well, I don't know. You guys know this. Give me a break. Look at this. So what do I do with 28 then? I break it up into a number I can do the square root of times whatever the shit else. And of course 28 is 4 times 7. See, there's an extra 7 in there, like there was an extra 1 up here. So then I do the square root of 4 because I can. I don't do the square root of 7 because I can't. What is the square root of 4? 2. Square root of 7 is? I don't know. Mixed number. Whole number. Rational number. Irrational number. There's a radical number. Whatever you want to call it. Now some people don't like this method. So I show you a second method. Look at how this same problem looks now with this second method. It's related to a square root is looking for how many things on the inside. Why can I do the square root of 9? Because 9 has how many 3's in it? 2. A square root's looking for groups of 2. So that's kind of like what the other method is based on. I don't like this method as much, but if you do it, I'm not going to treat you worse. You understand? You pick which one makes more sense. So what you do is you take the number on the inside. I like this screen better. I don't know why. Take the number on the inside, you break it all the frickin' way down, and then you just look for your pairs. Now the mistake, and do you see how I rewrite it? Since there's 2 2's, I can put a 2 outside. But what I always get is somebody puts 7 rad 2. You see numbers and you guess where to put them. The first method is very clear about why, what is where. Square root of 4 is frickin' 2. That's where it's a 2 outside. Here it's like, let me just put the numbers. But again, if you like this method, if you've done this method before, continue doing it. Just be careful. The other method is very, very prescribed. You're not going to make that same kind of mistake. So the 2 minutes I got left, do this first one. Now, I could break up 50 as 5 times 10, but why is that not smart? Because neither 5 or 10 is square rootable. Right? So how would I rather break 50 up? The 25 times 2. This is the square root of 25 times the square root of 2. Square root of 25 is 5. Square root of 2 is, I don't know. All right. So I think we'll finish this one up tomorrow. Tomorrow? Yeah, tomorrow's Thursday. I'll see some of you guys. Remember, let's start in the lab, and then whoever wants to come outside for me for the walkout thing, you can. If it's raining, I'll understand if you don't want to walk out.
So tomorrow at 9 we're not meeting here. We're going to meet in the lab.